right, this is your notes on randomized block design. So you picked this up when you came in. And so the key here is that we are going to be blocking items together. So blocking is putting things that are similar together in the same block because you think that whatever that trait is going to affect the treatment in some way. So let's kind of go through here and read some of the stuff that's put down here, and then we'll do a few examples. So, okay, I'm just kind of reading, but I'll say some things as I go along. So it first talks about that when you want to compare two or more populations. So you have a couple of things like maybe you need to treat the men as one group and the women as another population. You want to decrease the variability. Okay? Decreasing the variability within the samples. You know what we're doing when we decrease the variability? We are making homogeneous groups. Because if we think that the hormones versus males versus female are going to affect the medicine, then we want to make a homogeneous group of males and a homogeneous group of females. All right. Block design is called blocking when you do an experiment, just like we did stratified for sampling. Do you remember when we took samples and we divided them into we divided everything into small, medium, and large rectangles so that we could get some of each? The reason that they are called different names is because they came about separately. See, they were developed separately for sampling and for experiments, and so that's why they have different names. All right, and of course this happens because then you can have precise overall conclusions so that you are accounting for differences that are occurring because of gender or some other characteristic that you need to deal with. All right. A block is a group of experimental units. So it's going to be a group of men, okay, or a group of women. And so then what you do, they are similar in some way. They are homogeneous groups, and that would affect the outcome of the experiment. So in a block design, the assignment of the treatment, so when you put them into their treatment groups, it is done within each block. So what that means is, if I have some people and I think gender affects it, then I will then block into males and block into females. So these are blocks, and I'll be saying the word block here. Okay, and then this is just that's an experiment. So I'm going to do this experiment. I'll have to divide into sections, and this will be experiment. So I'm basically then going to be running two parallel experiments, one for the males and one for the females. We're doing this to control the effects of an extraneous variable. In this case, with males and females, it could be the hormones, whatever. Something, maybe smokers, non-smokers, maybe cholesterol level or different weight groups, underweight, overweight, obese, or different age groups, and so on. So that you bring the variable you control that variability. You control that, put everything into one group so that the variability within a group is reduced. All right, so let's do this problem here. Let's see here. If needed, how's blocking variable? Okay, so if you want to know how to choose a variable, the way researchers choose that is they choose the one that is most highly correlated or has the strongest association with what is happening, what you are checking for. So, in our case with, say, a blood pressure medicine, if I think that hormones have a significant impact on the benefits or the effectiveness of the blood pressure medicine, then I would block with gender because it would have the biggest effect on the effectiveness of the medicine. All right, so let's do this problem here. It actually is the same problem that you had for number 1 on your chapter 13 homework, but there's some things added to it. So this is the 4-month period of 30 bipolar disorder patients. They were given the high dose of omega-3 fats, the fish oil, 10 grams versus a placebo. Okay, and then they could see the results from this psychiatry article say that there was significant improvement for those that had the omega-3 fats over the placebo. Now, here's something added to this problem to demonstrate blocks. Suppose that some of the 30 subjects were very active people who walked a lot or got very vigorous exercise several times a week, while others tended to be more sedentary. So we have an active group and we have a sedentary. Consider tackling the confounding variable. Remember, confounding clouds the issue, where we can't tell if the improvement is because of exercise or if it's because of the omega fats. So we are going to control exercise so that we have only a conclusion about one thing, and that is the omega-3. All right, so let's start this. We start with our 30 bipolar patients, 30 bipolar patients. Okay, and the first thing you do is control the variable that could be confounding. So let's first make these groups as similar as possible. Let's make a group that is active, and let's make a group that is sedentary, since the description, most likely is talking about that because they think that is something that could confound the issue, so that we do not know if that is what's creating the improvement of disorders, or if it's if the medicine is, or if it's the exercise. So we will first block. That is the same thing. So what we say here is we are blocking. Okay? So that's another thing that we write there. Anytime you choose to block, you explain why you chose to block. And you know how we do this thing. We do our little pointing and then we describe it. So we decide that we are going to block by exercise. Okay? So why did we choose to block by exercise? Because it is possible. So we block by exercise because it is possible that exercise level has an effect on the improvement of the disorder. Okay, so again, the improvement of the bipolar disorder. So again, you are blocking because you think that is confounding the issue, and you cannot tell if improvement is because of the medicine or because of the exercise. That is why you choose your block. So, these are patients in the study that are active. These are patients in the study that are sedentary. You notice I am not putting a number with that. Why am I not putting a number? Well, that's because I do not know how many that is. So I have my 30 volunteers or whatever it is, and then I ask them, or I somehow, probably have them collect information so it's not a response bias. I learn if they exercise regularly or not. Okay, notice that at this time, I'm going to perform parallel experiments. Okay, it's almost as if you perform the experiment, with the top half, okay, and then you perform the experiment with the bottom half. So look, I'm going to perform this experiment with the active student or active patient. So what I would be doing is taking them, and I don't know how many are in there, so I am going to randomly assign and what we should be doing, is saying how we do this. Big bag, shake well, yada, yada, yada. Okay, so I'm hoping that, I'm going to kind of leave that off for now. Big bag, shake well, blah, 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 and we put half of the patient's here with the 10 grams of fish oil and half of the patients that exercise with the placebo. Okay, so do you notice that I do not have actual numbers because I don't know how many numbers there are in the active group. So however many there are, I'm going to put half in one and half in the other, and I don't know what you do if it's odd. So we'll figure that out once we come to it. All right, so you end up writing the exact same things down here. This is going to be identical. You got random assignment. I'm just going to kind of write this in a different color because it's kind of just a shadow. This sedentary group does identical things as I just wrote up above. Okay, I'm doing the same thing with sedentary as I do with the active. So then once I do that, same thing that we normally do. We do the thing where we, what is it? We got time going on, and then what do? We get the average improvement. Average improvement. Okay, and then after we're done, we are going to compare average improvement in the exercise group. So these people all exercise. This group up here all exercises. The only difference in those two groups is the fish oil. They all exercise. Okay, and then likewise, down here in the bottom, it's the same thing. We're going to get average improvement. Here, average improvement, and then compare their average improvement. The only difference between these two groups is that they took the 10 grams. They are both sedentary groups. They just take the medicine or take the placebo. All right. So that is what blocking does. So in recap, you block first if there is a trait that could confound the improvement, in this case, the improvement. If something that they do some difference between them could confound the improvement, and we can't leave it just to choice. We can't just pretend like complete randomization. We'll put the same amount of active and sedentary in each group, so we control it. All right, now, next section is about matched pairs. Okay, so matched pairs is also similar to blocking, but in that it also reduces variability. Okay, it reduces the variability a lot because what you end up with is, so a matched pair is one kind of block design. Each pair is its own block. what you do is you find a pair of things. You find a pair of people, you find a pair of tomatoes, you find a pair of whatever it is that you are going to be doing an experiment upon. You find a pair of rats, you find a pair of tomatoes, you find a pair of, Finnish women, whatever, that are very, very identical in almost every single way. All right? And then you take each pair and you will randomly assign one in the pair to a treatment, and then the other in the pair gets whatever else. All right. So each block consists of only 2 units, only a pair. They are matched as closely as possible. Then these units are random. Once you pair them up, then you toss a coin, or you put them both in a bag and pull one out. The first one pulled out goes to whatever. Okay, so you're going to toss a coin, whatever. You alternate. You make it so that one of them in each of them, one of the pairs, one of the items in the pair gets one treatment and the other one gets the other. So each block. Okay, another way that you could do this. You could also do this a different way. So one way is where you have the matched pair. One of the pair gets one treatment. One of the pair gets the other treatment. Okay? Alternatively, you could have one subject who gets both treatments. For example, in your Frappy that you did last night about the boots. Now, I know that I threw this out there to you, but I expected you to just do it randomly. But what we could do is, if you have the boots, then you could have the situation so that a person is a matched pair. One person is a matched pair. And because then they can serve as his or own control. They go all the same places. They walk at the same amount. They walk at the same pace. They go. Their feet essentially go through everything similarly. You would want to, halfway through the experiment, switch the boots around. So randomly assign the treated boot to the right, whichever foot. Treated boot goes to one foot. And then, 3 months later or whatever, they switch the situation. They don't switch their boots because they can't change the right and left boot, whatever. But they get a new pair so that the treated boot is on the left foot. All right. Anyway, so that's 2 different ways. Either 2 different people in them, one gets one and one gets the other, or you have them switch halfway through. All right. Now this example here references number 4 from our notes that we did yesterday about acres of land. I'm going to read that to you real quickly. That problem that we did, we kept skipping it. We just never really got to that. So basically, that problem, number 4 that we skipped on our previous information, was this. We wish to determine whether or not a new type of fertilizer is more effective than the other, so the researchers divided a 20-acre farm into 1-acre plots. Wheat will be planted on the farm, and at the end of the growing season, the number of bushels harvested will be measured. How will you assign the plots? So what we did in this case, because it's all we knew, is we would put all of the acres, we'd number them all, put them in a bag, and pull out the first 10. And those first 10 would get one treatment, and the other 10 would get the other treatment. So it was completely randomized. All 20 acres went into a bag, and we pulled them out. First 10 got. So those could be scattered amongst the 20 acres in a very strange way. In this case, let's read. Suppose that the experiment using fertilizer on the 20-acre farm described in the previous handout has been redesigned in the following way. 10 2-acre plots of land. This 2-acre plot of land is considered a matched pair. Okay, so it is scattered throughout the county and they are randomly selected. So we have 10 2-acre plots randomly selected. Each plot is subdivided into 2 subplots. So you have all of these little plots. There's your plots around the county. Okay, you got 2 acres and you have them subdivided. One of which is treated with the current fertilizer and the other of which is treated with the new fertilizer. So one gets the current, one gets the new. Now, you need to randomly decide. You do need to put them in a bag, or flip a coin. Let's see, how would you flip the coin? Okay, I guess what I could do is take this one on the left, flip a coin, and if it gets heads, then it would get the new fertilizer. Okay, and then if it gets tails, then the left side gets the current fertilizer, whatever. So you randomly assign, so it's not always the left one that gets the new fertilizer. You are not always picking the left to get the new. Sometimes the left plot is new fertilizer. Sometimes the left plot is current fertilizer. All right. Wheat is planted on the crops and the yields are measured. How is this experiment different from the same problem in number 4 on the previous handout? What advantage is there for this method? Which treatment is acting as the control group? And what information, if any, can be gained? Okay, so the first question is, how is this experiment different from the previous handout? Okay, so the previous handout, previous problem used completely randomized design. Okay? And, in parentheses, that's because all 20 acres went in a bag and you shook, and then you just pulled out 10 for the new and 10 for the current. So just by pure randomness, they could have all ended up on the same side of the county. The first 10 could have ended up on the same side of the county with very lush, near the river land. Okay? So if you want to control that so that every single new fertilizer is by the same type of location that the current fertilizer plot is, so that if they're sprinkled throughout the county, then you're getting all different kinds of lands, then you would use a matched pair design. Okay, next question. What advantages are there for this method? Okay, so I just said we can control variations in location. Soil, nice soil because it's near a river, type of wind, type of sun, all those different things we can control because they are in different parts of the county. Next question. Which treatment is acting as the control group? All right, so the control group is going to be the current fertilizer plots. So you'll end up having 10. There are 10 of them. They're just sprinkled throughout the county. Okay, you'll end up having 10. And what information can be gained by having the control group? So what information can be gained by having the control group? Well, you have a form of reference. You can reference the regular crop yield to see if new fertilizer fertilizer yields more. Alright, so let's do one problem left. We've got one problem left I want to do with you. And so here we go. Number 3. You are participating in the design of a medical experiment to investigate whether a new dietary supplement will reduce cholesterol level of middle-aged men. Okay. Dietary supplement, and we're dealing with the reduction of cholesterol, and we're dealing with middle-aged men. Okay. 60 randomly selected men. What does this mean? If they are randomly selected men, we are going to get to generalize to all middle-aged men when we're done. Okay? They are available for the study. It is known from past studies that smoking and weight can affect cholesterol levels in men. So this is something that we need to control. If I put smokers and non-smokers in the same group, then I cannot tell if it's the dietary supplement that is helping their cholesterol, or if it's the smoking versus non-smoking. Same thing with the weight. Describe the design of an appropriate experiment. Is blocking necessary in this case? Well, I think I just answered that. We do want to block to control confounding variable of smoking and confounding variable of weight. Now, we'll talk about blinding here in a second. I'm going to tell you this. On the AP exam, you will not be required to control more than one variable. All right? This kind of makes it confusing, more intense when you have two. So just for today, let's skip this weight, because I guarantee you on AP, you only have to control one variable at a time. So let's just do that for our example. Maybe tomorrow I'll talk to you about how we would do both of these. So we start with our 60 randomly selected middle-aged men. Okay, the first thing we do is control something that we think is going to affect their cholesterol level. And what is that? We have to block to control something, and we are going to block them into smokers. Now, do I know how many there are? I do not. It doesn't tell me. So I'm going to get those 60 men and then ask them, do you smoke or do you not smoke? So I got smokers and non-smokers. So I do not know how many people that is. But I have to tell people that I am blocking because smoking is a possible confounding variable to cholesterol level. Okay, so I am going to block to control, its effects. Okay, so therefore in my blocks, if there is an improvement, it is just then because of the dietary supplement. All right, so here we go. We are now going to go ahead and do our little experiment. And remember that these are basically two parallel experiments. I'm going to do one with the smokers, and then I will end up doing the identical thing with the non-smokers. So what would you do with one of these groups? We're going to split it into half of the smokers, half of the smokers. Okay, and what have I done to get them into those groups? I randomly assigned them. big bag, shake well, yada, yada, yada. All right, so now with that, I am going to give one of these groups the supplement, and one of these groups the placebo. And what am I going to measure? I'm going to measure average cholesterol improvement. Average cholesterol improvement. Okay? And so then I've got average cholesterol improvement. And then after I'm done with that, I'm going to compare average cholesterol improvement. So the only difference between these two groups is the supplement versus the placebo. Smoking is not an issue. They all smoke, so they are all the same in that regard. And then we do the same thing for the non-smokers. We split them identically. This will look exactly the same. Alright, so that's how you do that design. Now, before I leave you to do numbers 4, 5, and 6, I want you to do numbers 4, 5, and 6 for homework. Okay, and you can work on this in class if you have a little bit of time, especially on this number 4. We want to test 2 different memorization methods. They are wide ranged in age of the 120 subjects. So, the psychologist is concerned that difference in memorization capacity is due to the age. So, I want to give you a hint, since we have 2 different hints pair. I want you to start with your 120 subjects. I don't know if they were randomly selected or whatever, okay? But what I want you to do is take all of these subjects and so on, and basically you're going to have 60 pairs. You're going to, and so I'm just going to kind of describe this. I will have 60 pairs. And I'm going to explain what I have here, okay? So in essence, I am blocking them. So this is me blocking them into 60 pairs. Okay? So the pairs are made of subjects closest in age. You know, so I'll like figure it out. And if they're both 18, then or if I have 5 18-year-olds or whatever, then surely I can still match them month-wise closest to each other. So pairs are made of subjects closest in age. So once I have 60 pairs, then what do I do? Let's just pretend like for each pair, so for each pair, let's now go on and say what's going to happen. One will get one, you know, they're going to go like this. So for each pair, one of them gets the first method, and the other one gets the second method of memorization. Okay? And then you're going to go here and you're going to do some stuff, and okay, and you know how that's going to work. What are you going to put right here where these lines are? How are you going to figure out which member of the pair gets the first method and which member of the pair gets the second method? If you do this by judgment, then you could put bias into it. So, you must randomly assign, and I want you to tell me how you did that. I want you to describe how you chose. So however you want, I don't know, I want you to write that out. How you chose to randomly assign one in the pair to the first method and one in the pair to the second method. Alright, so in summary, your homework is numbers 4, 5, and 6. You have a matched pair and you have block. Control the block first. So I want you for the rest of the class to work on those numbers 4, 5, and 6, and I will stamp those and your frappies when we get to class tomorrow. Again, numbers 4, 5, and 6 on these notes. You do right now with the help or homework. And then that and your Frappies I will stamp tomorrow.